Hello dear students, welcome back to NEET World. So in this session we will continue our discussion for IPE for both Telangana and AP students, second year chemistry part here. Okay, and in this session I will be particularly discussing 2 marks questions from D block and F block elements along with the coordination complexes or coordination compounds. Okay, right. So let's begin our session. Yes, before that, see, this is our C16 material. Yeah, you can access this material for free of cost from our NEET World app. So just go to Play Store and download NEET World app. There you can access this complete PDF. Okay, so now what is the use of this PDF? Yes, this notes this material contains all the important questions from each chapter to get 60 out of 60 in your IPE exams. Okay, right. So it will be available for first year and second year students for all the groups. For me, it means like BPC and MPC students for all the subjects. Okay, right. So you might be from Telangana or AP. Yes, you can access it for free of cost from our NEET World app. So just download it from Play Store, log in using your mobile number. That's it. Okay, then next you just mention your class and group in the chat box. Then our team will guide you how to access this material. Right now we will be discussing the very short answer type questions. See, if you see this index paper ones, we have discussed solid state solutions is also over, and then next here today we will be discussing D and F block coordination complex is completed, polymers also completed. Okay, and the next when it comes to short answers, solid state completed, surface chemistry, and the next P block, D block is also completed, right? So all long answer type questions are also completed, right? So the remaining things we will be continuing in this discussion, right, in the upcoming discussion, but here we will be sticking to this D and F block elements as of this session. Okay, right. So now if you see this, yeah, let me show you once. Yeah, if you open the PDF or this module from our NEET World app, you will be seeing it like this. Okay, so whatever we have given there, we will be discussing here so that all the students who are watching this feel very easy and comfortable, right? Yeah, so right, you can understand each and every line that we have provided here from these sessions. Okay, right. So the first question says from this D and F block element, the first question says what is lanthanide contraction. So how can we explain this lanthanide contraction? See, if you look at the periodic table, so what we have, periodic table will be having like different blocks, right? So here S block, and this side P block, and in between D block, and at the bottom of the table we have F block right now. So now actually this F block element should lie in the three, like in this D block, in between that only we should have right now. So but it is placed at the bottom of this periodic table right now. So what is the reason? Yeah, so it's not about reason here, they are asking about lanthanide contraction. So what do we mean by this? See, as we move from left to right, just read, as we move from left to right, size decreases for F block elements right now. Size decreases for F block, even for other block elements also it is decreases. But if you see, the lanthanide contraction is steady decrease in the atomic radii and ionic radii of lanthanide elements from lanthanum to lutetium. From where to where? From lanthanum to lutetium as atomic number increases. Why it is happens like this? This is due to poor shielding of f orbital electrons. See, when I am saying F block elements, for all that F block elements, why we are classified them as F block? Because the last electrons are entering into the F orbital right now. The valence is the last electron is entering into the F block element, F block orbital, like F orbitals, right? So due to that reason, that elements are considered to be F block elements. Now what happens, you know, S orbital, if you consider, it will be spherical and symmetric around the nucleus. Okay, it's closely like symmetric around the nucleus. But when it comes to F block orbitals, I mean F orbitals, now they will be having very poor shielding capacity, whereas S orbital very symmetric around the nucleus now, so it will be strongly hold that nucleus charges present on that electrons. But when it comes to f block orbitals, what happens is it will not shield or it will not protect the valence electrons from the nuclear forces. Now what happens, that valence electrons will be strongly hold to the nucleus due to this poor screening or poor shielding of this f orbital. So due to that reason, what happens to the size decreases. So you can see this is due to poor shielding of f orbital electrons. Okay, so what is lanthanide contraction? The steady decrease in the size due to poor shielding of f orbital electrons. Okay, that's it. This is about the lanthanide contraction. Okay, so you write in the smoother manner. Okay, now next let us go for the next question. Scandium is a transition element but zinc is not. What is the reason? See, how can we classify an element as a transition or a non-transition element? It is simply based on availability of any unpaired electron or empty d orbital in the empty d orbital in their valency. Okay, for example, if you see from scandium to copper, what happens? Either in their atomic state or in their stable oxidation state, they might be having one unpaired electron or one empty d orbital or some empty space is there in the d orbital, valency d orbital. When it comes to zinc, in their elemental state or in their +2 most stable oxidation state, we will not be having any empty d orbital right now. Therefore, this zinc family or zinc block, like whatever the zinc group is there now, that should not be considered as a transition metal. It should be called as a non-transition metal. So what is the minimum criteria? See here what I am saying. They should have some vacant d orbital, then we can say that element as a transition element either in their elemental state or in their free state. So just see here, scandium is having electronic configuration of argon 18 over scandium atomic number is 21, right? So scandium 21, argon 18. So 3 more electrons I should read, right? So that is 4:3d1. Okay, so has a partially filled d orbital, hence it is called as a transition element. So what is the primary criteria? There should be some partially filled d orbital. Okay, then we can say that as a transition element. Okay, there should be some partially filled d orbital in their elemental state or in their most stable oxidation state, then we can say it as a transition element. Okay, but when it comes to zinc, see, if you see argon 4:3d10, so either in their zero oxidation state or Zn+2 also having 3d10 electronic configuration right now. So it has completely filled d orbital, hence it is not a transition element. It should be considered to be a non-transition element. That's it. These are the 2 lines you need to mention. Okay, I hope you got the clarity that what do we mean by transition and a non-transition element, right? So read the next question, what they are asking. Okay, then next here, why zinc +2 is a diamagnetic whereas Mn+2 is paramagnetic? What they are asking, why Zn+2, zinc +2 is diamagnetic whereas Mn+2 is a paramagnetic? So how can we answer this? In order to get this, you need to know their atomic number first. See, atomic number and their electronic configuration, if you are aware, easily you can do. Okay, especially their electronic configuration we need to know. So zinc +2, it means atomic number is 30. So after argon we will be having 3d10. 4s2 is the electronic configuration for zinc metal atom. But here Zn+2 is there now, 4s 0 electrons. Okay, here manganese atomic number is 25. It should be 3d5 4s2, but +2 charge is there, remove 2 electrons, so it becomes a 3d5 4s0. Now what is the question they are asking? Zn+2 is diamagnetic. Why it is diamagnetic? See, how can we identify diamagnetic and paramagnetic? If there is any unpaired electrons in their orbitals, then we can say it as a paramagnetic. If there is no unpaired electrons in their orbitals, then you can say it is a diamagnetic. See, here all electrons are filled, no unpaired electron is present in zinc. So because d orbitals are 5 here, like this 5 are there, so 10 electrons are there. Each orbital contains 2 electrons like this. See, all electrons are get paired up now. therefore no unpaired electrons, so number of unpaired electrons 0, so magnetic moment value is 0. So you can say this as a diamagnetic substance. But when it comes to Mn plus 2, there are 5 unpaired electrons. See, if I write 3d orbital like this, okay, how many electrons are there? 1. Like this we have 5 unpaired electrons, right? So if there is 5 unpaired electrons, definitely it will be a paramagnetic. At least one unpaired electron present, you should say paramagnetic substance. Okay, right. So how can you calculate magnetic moment value for further understanding? N into n plus 2 Bohr magnetons you can use. Okay, right. What is this n indicates? N indicates number of unpaired electrons. Okay, that's it. So now look at this. What is the next question? Aqueous Cu plus 2 ions are blue in color, whereas aqueous Zn plus 2 ions are colorless. So what makes the difference? Once again, aqueous Cu plus 2 ions are blue in color, whereas aqueous Zn plus 2 ions are colorless. So here, whenever we are placing a metal ion in the ligand field, that is here they mentioned aqueous, it means we are placing copper plus 2 ion in the water medium. Now what happens? Water molecule will surround this positively charged copper plus 2. Now what happens? See, copper plus 2 ion has 1 unpaired electrons in the 3d orbital, which allows the 3D transition, giving the blue color. So now what happens is it will form a complex. So when you place this aqueous plus 2 ion in this water, it will form a complex. After forming the complex, we know there will be d orbitals in the copper plus 2 ion, right? Like this we have d orbitals. Okay, 5 d orbitals should be taken. Okay, 1 2 3 4 5. Okay, so now what I am saying here, Cu plus 2, it means you can write 3d9 electronic configuration, valence electronic configuration. So 9 electrons, 1 2 3 4 5 6 7 8 9. Okay, now these orbitals will split into 2 energy levels, like different energy levels it will be splitting. Okay, so now what happens is electronic transitions takes place from lower d orbital to higher d orbital. So due to that reason copper plus 2 will show blue color. Okay, so copper plus 2 ion will show blue color in this aqueous medium, not in dry state, here in aqueous medium. Okay, so Cu plus 2 ion has 1 unpaired electron in 3d orbital, which allows dd transition. That unpaired electron goes from lower level to higher, or higher level to lower. That electronic transition is there now, that is called dd transition, because it is happening in d orbitals. So that will be resulting to give a blue color solution. Okay, blue color to that copper plus 2 ions. Okay, hope the discussion is clear. Right, let's understand why Zn plus 2 is not colorless, not a colorless, not a colored substance. It is a colorless. Now why? Because when you take Zn plus 2, it will be having 3d10 electronic configuration. What it has? 3d10 electronic configuration. 3d10 means all the d orbitals are fully filled. Okay, like this. If all d orbitals are fully filled, there will not be any chance for dd transition. If there is no dd transition, there is no color for this Zn plus 2 complex. Okay, so that's why there is no dd transition. Zn plus 2 ion has completely filled 3d10 electronic configuration, so no dd transition occurs, hence it is a colorless substance or colorless ion. Okay, okay, I hope you got this clarity on this concept. Now in the same way, with the same concept, we have one more question here. See, copper sulfate, like CuSO4 dot 5H2O, is a blue color solution. What it is? It's a blue in color. Okay, not a solution, it's like CuSO4 dot 5H2O is blue in color, whereas anhydrous CuSO4 is colorless. It means, what makes the difference from here to here? Yeah, here we have hydrated salt, here we have anhydrous. It means no water is present. See, this hydrated salt is colored, it is a blue color, but here it's a colorless. What makes the difference again? Yeah, here also we have a complex, we have a tetrahedral complex here, but here there is no complex. So when it forms a complex, what happens? The orbital splitting takes place. Due to that, electronic transition takes place from lower d orbital to higher d orbital. we will get a DD transition, that is results for the color of that complex. But here there is no water, like there is no ligands, no, so it means no DD transition, no splitting of orbitals and no transition, therefore no color here. Okay, so you can see here in CuSO4.5H2O, water act as ligand causing crystal field splitting. Okay, crystal field splitting result in a blue color complex. Okay, due to the crystal field splitting, we may expect electronic transition and shows this blue color to that complex in the hydrated form. Whereas in anhydrous copper sulfate, no water ligands are present, therefore no crystal field splitting, hence it will not show any DD transition and there is no color for that complex or that compound. Okay, I hope you got this concept again. Next, what is a ligand? Give one example of unidentate ligand. See, it's very simple. So ligand is a species which donate pair of electrons to the central metal atom. Okay, so what do we mean by ligand? I will tell you, just listen here. See what I am writing here. See, we know there will be metal complexes. Okay, so at the center we have metal. To that, whatever the ligands present, they will donate pair of electrons. Okay, so now species which donating pair of electrons to the central metal atom is considered to be ligand. For example, I am writing here CuNH3 6 times plus 3. So here 6 ammonia ligands are there each time. Okay, so here you can take Cu or CO, let us say CO, cobalt complex is there here. So cobalt, now hexagonally, I mean octahedral complex here, where we have here ammonia as a ligand, like everywhere here we have ammonia ligands like this. Okay, octahedral complex here. Okay, so how many are there? 6 ligands are there. So these 6 ligands are there, now that is what the coordination number of this metal complex. Okay, number of ligands bonded to this central metal atom is considered to be coordination number here in case of monodentate ligand. Okay, right, read the statement. A ligand is a molecule or it can be an ion that donate an electron pair. See, the lone pair electrons present on the nitrogen of this ammonia is donated to the metal. Okay, the electron pair to the central metal atom or ion to form a coordinate covalent bond. Okay, a ligand is a species which donate pair of electrons to the central metal atom to form a coordinate covalent bond is considered to be ligand. Okay, examples of unidentate ligands are chloride ion, negatively charged ligand. Okay, ammonia, this is neutral monodentate neutral ligand. Water is also monodentate neutral ligand, and here cyanide ion is also unidentate ligand. Okay, these are some examples for unidentate ligands and definition of ligands. Okay, right. The next here we have give two reactions in which transition metals or their compounds act as catalyst. Yeah, there are many good applications in industrial process where we are using transition metals as a catalyst right now, because these elements, these D block elements consist of large surface area. So large surface area, and there may be some metallic defects also. Due to that, there might be some holes in which the gases can be accumulated, and that will be favors the chemical reactions like hydrogenation of alkenes. We are using nickel, palladium, platinum as a catalyst right now. So here we have, see, there are some other examples also in contact process. What in where in contact process, that is for formation of, for production of sulfuric acid, first we will produce or form this SO3, sulfur trioxide. So there we will be using V2O5. So V2 vanadium pentoxide is used where sulfur dioxide upon oxidation gives you sulfur trioxide in presence of V2O5 metal oxide. Okay, the next method here in Haber's process. What is this Haber's process? It is for preparation or the production of ammonia, for industrial production of ammonia. So what is a catalyst used here? Iron is a catalyst where nitrogen and hydrogen combines to give you ammonia in presence of this iron, the metal catalyst. Okay, now next question here, write spin only formula to calculate magnetic momentum of transition metal ions. Okay, so what is the spin only magnetic moment formula? I told you. First of all, a metal will show the magnetic nature when it have unpaired electrons. Okay, if there is any unpaired electrons, it will be a paramagnetic substance. Now, number of unpaired electrons, this is how much magnetic moment it has. Okay, so the number of unpaired electrons I am indicating with symbol N. Okay, N indicates number of unpaired electrons. Now the spin only magnetic moment, that is due to the spin of that electron, the magnetic moment value is considered to be mu, that is spin only magnetic moment mu is equals to root over N into N plus 2 Bohr magnetons. What is this? N indicates number of unpaired electrons. What it represents? Number of unpaired electrons. Okay, right. The next here we have calculate spin only magnetic moment for iron plus 2 ion. So how can we calculate this? The electronic configuration for this iron plus 2 is 3d6 4s0. What is the iron atomic number? 26 right now. So if we remove 2 electrons, it becomes Fe plus 2. So if we remove 2 electrons, it becomes Fe plus 2, means remove the 2 electrons from 4s orbital, then we will be having 3d6 4s0 electronic configuration, right? Now if you write this orbital representation, then you will get to know how many unpaired electrons are there. See, 6 are there now, 1 2 3 4 5. The 6th electron will be like this. So now unpaired electrons are how many? N is equals to 4. For 4 unpaired electrons are there, mu is equals to root over 4 into 4 plus 2 Bohr magnetons. Okay, like this we need to calculate. Okay, then root over 4 to the 4 plus 2 6 for the 24. Okay, so it will be around 4.9. Okay, 4.9, around 4.9 Bohr magnetons will get. Okay, so this is how you need to calculate. Okay, so this is a spin only magnetic moment formula to be used to calculate the magnetic moment value for the metal ions. Okay, so the next question also in the similar manner we have. Yes, you can try this in the based on this above explanation. To calculate the magnetic moment value for a divalent ion in the aqueous solution of its ion. I mean that divalent ion is placed in the aqueous solution and having that divalent ion having atomic number of 25. So now what happens, tell me? Atomic number 25 means what is a metal atom we have? Manganese right now. So manganese divalent. Manganese divalent means Mn plus 2 charge right now. If it is Mn plus 2, we have 3d5 4s0 electronic configuration. So 3d5 means how many unpaired electrons are there? We have 5 d orbitals. Each d orbital contains 1 unpaired electrons. So total number of unpaired electrons are 5. Okay, so the N value is 5. Now mu is equals to root over N into N plus 2, that is root over N 5 into 5 plus 2. Okay, so 5 into 7 it becomes. Okay, so 5 into 7 it becomes, that is 5 7 35. Root 35 is equals to 5.92 Bohr magnetons. I hope you got this complete discussion of D and F block elements along with the coordination complexes 2 marks questions. Okay, and you know we have also made a session, I also covered a session here for 4 marks VSAQs from these coordination complexes, right? You just watch this 2 sessions on D block, F block and coordination complexes, and you can have your 4 marks question in your hand and you can have your 2 marks question in your hand. Okay, mostly they will ask from our discussion, I mean whatever the questions I have mentioned here. Okay, mostly, because most of the time those are the questions are repeated. Okay, right. Now you can watch the other sessions also which I have covered in this channel itself. If you really found them helpful, please mention in the chat box, and also you can share with your friends. Okay, so thanks for watching. Stay connected with our NEET World channel.